Recall.
All right, welcome to this week's Journal Club. Today we are doing the Features of Similarity by Amos Tversky in 1977. I am Mike. I'm the first year PhD student of T-Lab. I will be the host for today. And Vishaal?
Hi, I'm Vishaal. I'm a master student in the same lab. Lipeng select out.
Oh,
We might have to
we'll,
restart.
no, we don't have to. We'll just wait a little bit
Okay.
for Lipen to hopefully reconnect.
Ah,
Um,
can you hear
we'll
me?
pause. Oh, yeah, we can. Oh, yeah, it works now. Great.
Okay. I'm Lipeng. I'm a research assistant in the same lab.
Okay, great. Now, what is this paper about? Well, first, we need to talk about some background information about how people conceptualize similarity in the past. Now, similarity is clearly important to psychological studies. It's heavily related to how we make judgments about the external world, how we categorize stuff. Um, so it's very important to have a good model of what this similarity is. Previously, people consider similarity more like distance in a three-dimensional space. So if we imagine two different colors, right, maybe red and purple, they are in this three-dimensional color space, and the distance between the 2 points represent how similar or dissimilar they are. But Tversky realized that there is some problem with this type of description, especially when we are dealing with complex stimuli like faces or concepts such as nations. Things become really weird and wacky. So he is trying to propose a better model that account for all the problem that he sees. So what are these problems with the geometrical model of similarity? Well, there are three, but today we're mainly focusing on the symmetry aspect because this is what the paper is really about. So if we imagine the distance between 2 points, no matter which point you start at, the distance is the same, right? Distance doesn't change. So when we are making similarity judgment between a pair of objects, no matter which one we start first, supposedly, it shouldn't alter our similarity judgment because it's symmetrical, much like the distance. However, this is clearly not the case, even based on our conventional wisdom, right? Tversky's observation points out that salience often have a lot to do with the possibility of asymmetry similarity judgments. So for example, imagine we are comparing two nations. We're comparing Cuba and Soviet Union. It makes sense to say Cuba is like Soviet Union. But if I try to say Soviet Union is like Cuba, something feels a little bit weird, a little bit off-putting. It's like I'm making some kind of mistake, even though it's not obvious what's wrong with the sentence per se. The same thing applies to saying like, my love is as deep as the ocean. If I reverse it and say the ocean is as deep as my love, something doesn't feel quite right. Now, why is that? Tversky believed that the reason is because in this type of sentence, we have a subject and a referent. A is similar to B. A is the subject, B is the referent. In most cases, we put the less salient object to be the subject, A, and the more salient one to be the referent. Once again, for example, Cuba and Soviet Union. Soviet Union seems more salient. We have a stronger impression of it. We may have more knowledge about it. So when we say Cuba, the less salient one, is more similar to Soviet Union, it makes sense. But when we are putting the more salient Soviet Union as the subject and say Soviet Union is similar to Cuba, something doesn't feel right. This also applies to all the examples I mentioned previously. So that's quite interesting. That's a problem that geometrical model can't really solve. But how exactly is Tversky going to resolve these problems? Before I go into it, I would like to quickly share my screen because Tversky is going to introduce to us something called a feature matching contrast model, and it's best understood through graphs. So let's say we are comparing A and B, right? We have A, we have B. We can imagine them to be Venn diagram in terms of the features that they possess. If we're talking about faces, maybe it's the shape of the nose, the shape of the face, the color of the face would be considered as features. Symmetry, higher level concept like that will also be considered as features. Either way, when we are comparing two objects, we are essentially comparing their features. We would see some features they have in common and some features that are distinct to, let's say in this case, A, while other features distinct to B. Now, Tversky proposed that the similarity is simply a linear combination of these three elements: the common features, the A distinctive feature, and the B distinctive feature, right? There will be different weighting depending on the circumstances, but just by adding them together, along with the weighting, we should get similarity. So that's essentially that. Now, in the paper, Turkey made of axioms that he show that it's reasonable and reduce this linear model. But we will not go into it with too much detail here. But essentially, the idea is the combination of these in some fashion to form similarity. Now, it's always to propose a new model, but did Tversky have evidence to back up these new contrast model? And it turns out that he does. Now, we already mentioned the countries. They're using slightly different countries here, but the essence is the same. There's a prominent nation, there's a less prominent nation. They form a pair, and you need to make similarity judgment. And people much prefer to use the less prominent nation as the subject and the more prominent nation as the referent. So we will do that and move on to figures. Now, imagine that you have been shown two figures, for, let's say this figure here, and to the left top corner and the right top corner. And if you were asked to compare these two and say which one is more similar than the other, you probably would more likely to say that the picture to the right is similar to the picture to the left rather than the other way around. Why is that? Because the goodness of form supposedly indicate higher level of prominence and salience. So we see that in this case, we see good symmetry, very nice clean corners, while in this case, it's entirely chaotic. There's no symmetry here, really. So this figure is probably more prominent, more salient. Other than the goodness of form, complexity also can be a part of the salience factors. For example, the right corner figure is more complex than the left corner figure, so it's probably more salient, and you would probably, hopefully, judge that more willing to judge that the left corner figure is similar to the right rather than the other way around. All right, another interesting example that Tversky given is presenting the participant with a pair of letters. Not real letters, of course, but these 8 artificial letters. Now, what they are trying to do here is rather than to ask participant about similarity or which sort of judgment they're likely to commit, they are asking participant to judge whether the 2 letters are identical to each other And they assume that if the two letters are really similar, participants are more likely to make a mistake while making this type of judgments. And how the similarity works in this case? Well, the similarity works in the sense that the letter of comparison, if it contains the subsequent letters, then it's more salient. For example, let's say you saw letter E first, and then the second letter you saw letter F, then you need to press the button to say whether they are identical. Because letter F is its focal feature, a subset of letter E, right? You just need more little horizontal line to form letter E. So letter E is more salient than letter F. So you are more likely to mess. If it's the reverse, if you see letter F first and then we show letter E, are less likely to make a mistake because in some sense they are less similar to each other. So now that's quite interesting as well. That's what they found. One other thing that's also very intriguing. Actually, we also have Moscow signal here, but essentially the same as the letter example before. So I'm not going to the experiment in details. What I'm going to talk about is the prototypes and how similarity may affect prototypes. What does that mean? Well, consider the statement A is virtually B, right? It makes a lot of sense to say 103 is virtually 100. But it doesn't make a lot of sense to say 100 is virtually 103. It seems arbitrary to make such a statement, right? But this is in fact just the reverse of the former statement. Why is that? It's because we consider numbers like 100 or 10 or 50 to be more prototypical in comparison to number like 11, 52, 103. And because it's prototypical, it became more salient, and we are much more willing to use it as a referent rather than the subject. Great. So I have hopefully showcased a lot about the asymmetry aspect about these similarity judgments. We're going to move on to something a bit more tricky. We'll start by the elicitation of features. What does that mean? So in the contrast model, it's all about matching features with one another, right? We have common features, we have distinct feature A, we have distinct feature B, so on and so forth. So based on that model, we should be able to make a prediction about similarity by simply looking at how many features the participant can come up with, both in terms of common features and in terms of distinctive features. And it seems, based on the correlations, it sort of can be done. There are additional manipulation required in terms of how frequently a feature was mentioned. But in principle, it seems to be you can predict similarity just by looking at the number of features. So that's quite interesting. I will once again not go into the details because there are still two more things I would like to cover before I end the summary. Now, one very peculiar aspect that the contrast feature matching model can predict and the geometrical model cannot is that it's possible for a pair of objects to be both more similar and more different than another pair of objects. Sounds a little bit convoluted, but I will give an example here. So in this case, when asked to judge the similarity between West Germany and East Germany, participants decide that these two are more similar than Ceylon and Nepal. Ceylon is Sri Lanka, in modern terms, that is. However, the participant also judged that the difference between West Germany and East Germany is larger than Sri Lanka and Nepal. So these two Germany are both more similar and more different than Sri Lanka and Nepal. Seems impossible, but this is the experimental result, and based on Terzi's model, is be predicted, or it can be explained at the very least. And the final thing that we talk about is similarity in context. What does that mean, right? When we are talking about context, we're really thinking about the meaning of salience, how it may alter depending on the context of the objects that the feature space are given. So, for example, Tversky believes there are two factors that constitute salience. One is just intensity of the stimuli. So the bigger, louder sound, the more saturated red color, that's one aspect of salience. The other aspect is the diagnostic principle, the diagnosticity. What does that mean? So imagine, once again, we are comparing nations, right? But instead of just looking at pairs, we're looking at a set of, let's say, 8 different pairs. If these 8 different pairs of nations all came from, let's say, America, they're all American nations, then the diagnostic criteria of American doesn't contribute to anything. But if instead we have 4 pairs that are American nations and the other 4 pairs as European nations, we would see that the similarity between the American nation is boosted simply because of the presence of the European nation pairs. Why is that? Well, it's because if we're only looking at the Americans nations, the features of being an American nation doesn't jumps out to us. It's irrelevant. We disregard it. But when we introduce these European nation pairs, all of a sudden things changes, and we come to the realization that this is also a feature that we should consider. A less abstract example is by looking at these faces. Once again, a similarity really contributes to how we group things. So by manipulating how we create these clusters, and we can essentially manipulate the salience using these context effects. So for example, let's do a quick exercise to end this. Look at the picture A, the face in A, and decide from the pictures below which face is more similar to A. Now, when I was looking at it, I thought that, it seems that picture B is quite similar, right? And a lot of participants would agree. Almost half of them would say that, these two faces are most similar among all the potential 3 options. But if instead the participants was presented with the same task and almost the same stimuli, something changes. Instead of 2 happy face and 1 sad face, we have 2 sad face and 1 happy face. And all of a sudden, we see that the odds became overwhelming towards selecting the happy face instead of the split between the sad face and the happy face here. Why is that? Well, you see that we automatically categorize based on the option available. We consider the 2 happy face to be 1 cluster, and therefore it leaves the neutral face and the angry face to be in the other cluster, which boosted the insimilarity of the angry face. But in this case, we see that similarity face creates their own cluster, and the happy face is clustered with the sad face, and therefore the happy face is significantly boosted in terms of odds. So that's very interesting. Tversky also talked more about the sort of clustering and prototypes in the rest of the paper, but once again, I only have the hour. I wasn't able to finish all of it. So I will end the summary here. Yeah. Sorry, have I missed anything on comments or add?
I think that's a very good summary. And can I ask, when they present three phases or three country, what did they ask participant to do? Can I, because I didn't the reading.
No worries. So I think the setup was that different group of participants will be presented a set. We have two sets. So participant will be asked to judge out of three phases, which one is most similar to the phase A.
Okay, I see.
And the percentage is the how much percentage participant in the phases.
Oh, is it a
So
theoretical
there's
explanation? Sorry.
oh no,
No, okay, no.
don't worry about it.
No, I was gonna ask, is there like a theoretical explanation for the like is it the explanation for why it's a pretty even split in set one versus set two, where there is not an even split? Is the explanation in terms of just the similar like how participants respond to similarity experiments, or is it something beyond that? I haven't reached this part either because I mean there are two happy faces in the first set and there are two angry faces in the second set. So naturally I would have thought that it would be pretty inverted in a sense that 80% would also choose the odd one out, similar to the second set. But here it's pretty even. So is it like a aspect of a similarity experiment that results in this manner, or is it more of a psychological explanation for expression choices?
I know I also only skimmed these sections, so maybe Tversky has briefly made it, but I don't think he gave a systematic explanation regarding this specific kind of asymmetry. I would imagine the reason most likely is more psychological. Perhaps the participants simply bias the smiling face more when they're making similarity judgment. Maybe it's because some aspect of it's more salient in comparison to the angry faces, but it's a bit difficult to say. Yeah.
I have a comment because at the beginning of this paper, are we entering into discussion section, right?
Yes.
So at the beginning of this paper, this Tversky says that the representation of an object as a collection of features is viewed as a product of prior process of extraction. But recently, I also have read some paper that criticizing similarity rating. They says that to do the similarity rating, they assume that participant or one or the all dimension feature of an object is obvious to participant. But it seems that it is not the case. This assumption is not holded. So they instead using similarity rating, they choose odd one out. So to use odd one out, participant need to choose one object that is more different to the other two So that author says that the other two can act as a background to do the similarity rating or to judge the similarity. So that's why I ask you, what is the instruction um, when Tversky asked participant to rate the similarity of faces, and then when we go back to phenomenal qualia and the conceptual qualia, I think this kind of a feature or a collection of feature is also not very obvious to participant in terms of phenomenal qualia. But in terms of conceptual qualia, the language is communication tool. So it means that they are some aspect of feature that people use to describe an object. There 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 is predetermined dimension to communicate. So I think when we do similarity rating of phenomenal qualia, Tversky assumption of representation uh, of an object is collection or feature is a little bit hard to assume in this case.
Yeah, I think I agree, especially when we are talking about the phenomenon that
The
are
nature
quite
scene, like
simple. Like just yeah. Like well nature scene is hmm, uh would you say that the natural scene depending on the instruction, I guess. Like in
yeah,
your
yeah, yeah.
previous experiment, yeah. When I'm talking about emotion, does the hmm does the features of the natural scene matters, or rather, what sort of features matters? It's kind
Yes.
of difficult to see.
And I totally agree with what you have mentioned about the instruction. So I highlight some instruction of in this paper. In
Mm.
similarity of countries, they ask participants to select uh, in each pair the country they regarded as more prominent. Oh, I can share my screen.
Oh yeah. Sorry, I will stop sharing.
Uh, maybe so here, similarity of country. So Tversky want to test asymmetric, right? So they ask participants to select in each pair the country they regard as more prominent. And then in terms of figure, they ask to, let's say, the subset of similarity. The left figure is more similar to the right figure, or the right figure is similar to the left figure. Just similar to whether the son is similar to father or the father is similar to son. And then let's go to the similarity of letter. But here is different. They presented this stimuli in a temporal order or sequentially, right? And then they by using this temporal order, they assess the asymmetric effect. And then in the signal, they ask whether the two signal in pair is same or not. So to me, this four experiment or mm, four type of experiment, they use different instruction. Um, I am a little bit worried about the effect of this kind of instruction.
Hmm. I suppose if Tversky is to defend himself, he would say that even
Mm,
though we are using different kind of measurements and instructions, we are
mm,
consistently finding this asymmetry that his model predicted. So
mm,
that seems to speak well of his model, right?
yeah, yeah.
Hmm. Now,
Uh,
actually, I was, oh, sorry.
please, please.
I was actually thinking whether there is a world where we goes beyond pairwise comparison.
A
So
word.
sorry, rather the possibility of developing some sort of methodology to go above and beyond pairwise comparison,
Mm-mm.
and whether that would be interesting to see. But it's difficult to conceptualize how that would even work, or is that pairwise comparison is the only
What do
way
you
to do
mean
it?
beyond pairwise comparison?
For example, judge the similarity between three things instead of two.
Oh, I see. So can I paraphrase your question to see whether
Yes.
I understand you? Like to rate the correlation or the relation between object, is there any way beyond pairwise similarity to see the core to ask to get the mental representation different or relation between object from participant? Okay.
Yeah.
I think there are many it kind of related to my review idea presented last time. Um, yeah, I still it is a very tentative idea, and yeah, I agree with you. Order one out, or choose or rate the similarity of three objects, or rank the order between objects. They are possible, but which one is work better or work more efficient to represent the like a similarity or perpetual similarity? It is still questionable. Nobody have summary this kind of stuff. Yeah, your question is really valuable and aligned with
Thank you.
what I
Thank you.
thought.
Yeah, I'm just curious that if, let's say, the result of pairwise comparison is drastically different from these more complex comparisons, what does it say about the previous model that are entirely based on, constructed upon these pairwise models, pairwise comparisons? So yeah.
Mm. And
Mm.
I also want to add one thing is the like background effect or context effect. So remember in our labs experiment, in the color experiment, uh, they asked participants to rate the similarity between 93 color, but in that version of experiment, they present all color sets before starting the experiment. So the participants they have a concept or they know that they know all stimuli before rating the similarity. Kind of conceptual that. Or compared to that, in terms of emotion video, if I ask participant to rate um, a similarity between all emotion video, it is not possible to present them with all video beforehand, right? Before the main task, and then they have no prediction of what's coming up. I'm wondering whether you think this kind of background effect or context effect will have an influence on similarity rating.
Um, I think it will, right? I mean, similar to what Terpsky talks about. Depending on how you group the stimuli, you may reach you may make judgment using different features.
Yeah.
Um, but in this case, if we I'm a little bit uncertain about the 93 color one, just because there are so many colors, and it's kind of difficult to categorize, even if participants were able to view it beforehand. But so it's a bit difficult to say what sort of effect it will have.
How about
Just to clarify, for the 93 color data set, the participants were shown the data set first, but for the emotion one, they were not shown the video. Um, uh, isn't the justification for that for um, the color data set there were some pretty ambiguous colors, if I remember correctly, and so um didn't they need to like establish? I don't know. I don't remember exactly, but it was something about getting the clarifying specific colors. I don't remember. I don't remember exactly. If you remember,
What do you mean by ambiguous color?
not as in uncommon colors, so to speak, like
Ah,
those with the weird names. You know? So
no,
no,
there
all right,
no
okay.
no unusual color. So that's the question. If we have a such kind of unusual color in our data set, and we present it before the experiment, and we don't present it with that, and that they were surprising. Maybe my similarity rating will, their similarity rating will change after they seeing this kind of unusual color. That's what I thought. This kind of background effect. Tversky also mentioned that. Okay. Yeah. Maybe I can show you the 93 colors they present. Let me share my screen again.
Yep.
Yeah, this one.
Ah,
Yeah, so they will, or in the Ariel's experiment, they will show participant all color, upcoming color. So participant will have expectation. But if we don't show them this kind of color, at presumably at the beginning, they will see this light yellow and a yellow and then this kind of all yellow. So they will have expectation that, oh, am I going to rate the similarity in this um in this range of yellow? And then suddenly it comes up, oh, there's blue. They will update their expectation.
now looking at it, it does feel like there is some kind of category that maybe the participant can make to sort the color into clusters. Maybe depending on the like how common these color appears. I feel like while I was looking at it at least, some of the
Mm-hmm.
color seems more natural, if you get my meaning. For other color, be it more light or darker, it feels very unusual. Or maybe there's a that's a cluster that can be made here, even with like 93 different colors.
Mm.
Does that make sense, or is it just me?
You're talking about the um horizontal lines,
Yes, the
right?
horizontal lines.
Because
Yeah,
they're
something same.
dark, bright, dark. Yeah.
Uh, not necessarily in terms of their sequence, but just in terms of how
I mean like the
common they are.
class. Yeah. Oh, common.
Yeah,
Okay.
yeah, how usual. Well, when I'm thinking about, let's say, the color red, I'm not thinking about light. I'm often not thinking about darker red. It's probably the prototypical red. More prototypical would be the word. Yes. I feel like some of these colors are more prototypical than others. Does
I
that make
mean,
sense?
I would have, if I were the participant, I would have listed it as lighter than standard or darker than standard, which is why I said yeah. And if you notice, the rows were sorted like um one after another. Yeah, a darker shade and a
Mm,
lighter shade of a given color. Yeah.
yeah, yeah. Mm,
But emotion is pretty different from color though. Like I feel like it's a bit more, I don't
I,
know,
I agree with you. So
subjective. At the
sometimes,
same time, yeah, sorry.
I mean, yes, sometimes they will update some kind of expectation during the experiment. That's what I'm considering. Mm.
mm.
Uh, can I? Can you explain a little bit more about diagnostic factor and intensity factor because I haven't read that.
So in the in intensivity is simply referring to uh, how intense a stimuli is. Louder stimuli, more saturated colored stimuli are considered to be more intense and therefore more salient. And the diagnosticity is related to this grouping effect we talked about. So the first example they gave was if we are considering the realness of an animal. If I show you 10 just normal, your run-of-the-mill animals, the realness doesn't matter. But if I put a unicorn in there, suddenly being a real animal matters a lot. And it becomes a criterion that you will be used to judge similarity.
Yeah. Thank you for the clarification.
Sorry, my throat is a little bit dry. Are there any other questions or point of discussion? I mean, if not, I would like to add one final point. Sorry. Regarding the conceptual similarity, rather Amy's experiment. When for the audience that doesn't know, so she was an honor student of our lab, and she done this experiment where she shows you two words, one emotional word, color word, and ask you about similarities. And she found some very interesting correlation that exist that doesn't exist if you instead show a picture of the color and then the emotional word. So it seems that some similarity, if we are considering the features, the word blue possess features that the picture of blue doesn't have. And that's very interesting to me because I can't really wrap my head around it. Because isn't the words blue just supposed to be a representation of the actual blueness? Why surely the blueness is more than the word blue, rather the other way around, right?
So, your question is about the conceptual blueness should be similar to what they have really see, the blue patches.
Yeah, and I think the point is that the phenomenal blueness sort of covers conceptual blueness, it seems to me, at least intuitively in some way. Because you see the blueness, you feel the phenomenal blueness. You, of course, have an idea of what you saw, right? You know that conceptually it's blue. So what's going on here?
Mm, to me, I don't think they are this kind of subset relationship because a simple example is GPT. They learn everything conceptually, but they haven't see any blue. So, if I go back to emotion, like I am a baby or just somebody that don't learn language properly, then I would say, oh, maybe anger is similar to happy because I don't know these two word meaning, but phenomenally, I know anger is different feeling to happy. So I would say maybe they are two independent or phenomenal qualia is independent to conceptual qualia. May I ask, why do you think it is subset relationship?
But because it seems to me that, for example, remember we did a paper on they use they strap a camera to a baby,
The baby.
they record yeah, and they
Right.
train an AI to
Which one was that? Like
I
post.
can't remember the name.
Okay.
The language acquisition.
Yeah.
So
So,
please.
oh, sorry. I was just thinking that if you have a conception of you have seen a phenomenal blue, and you have some like learned relationship between the word blue and the phenomenal blue. It seems to me, at least, the learned word is but like a representation. It's included in these experience, but I'm not sure if that's a well-formulated idea or not. Maybe I have ignored some crucial aspect.
I
Um,
get what you mean. There's another explanation, maybe to me in that paper. The grounded language acquisition is about the mapping between phenomenal and the conceptual.
uh,
So these two domains can be independently learned, but the grounded language acquisition is to map together. When I see blue, I heard blue. Then I build a connection between these two things. Or then I say, I gain the meaning of blue is seeing these blue patches. But also you mentioned that if it is subset relationship, then I first learn what is blue or learn this kind of phenomenon of blue. Then I have a conceptual thing, BLUE. It is blue, and then I add it to the phenomenon of blue. Is that what you mean?
yeah, that's kind of what I mean. But now I think about it, I don't think that's a very good argument here. Largely because the language acquisition doesn't necessarily correspond to the conception of blue. So I was thinking, oh, what does the word blue means other than referring to the phenomenon? But beyond that, the word blue has no meaning.
I mean,
But yeah,
so it's kind of like that the thought experiment about Mary in the black and white box thingy, right? And
Right.
she's an expert of color. You know, she knows everything there is to know about color, theoretically speaking, but she's lived in a room that's purely black and white all her life. And then when she steps out of the room and looks at the world full of color, does it line up with her expectations or does it not, right? So that's that. So yeah, it's a very similar discussion. Yeah, I feel.
yeah, certainly. But now I think about it, when you look at a bunch of different blues, we have a abstract idea of what is blueness, and the word blue may be referring to this higher abstract concept that can correspond to different kind of blue phenomenal blue that we all call blue. So really, they are interrelated, but fundamentally like separate domain. So yeah, that's a better conceptualization. Yes.
Now maybe we'll go back to the Amy's experiment. So Amy experiment is testing whether normal people have a different conceptual qualia structure compared with depression people. So the result showing that phenomenally, normal people and depression people have same phenomenal experience, but differ in terms of conceptual experience or conceptual qualia. So that's what Amy's result suggesting, I think.
Yeah. I didn't mention that, but yes. So just to quickly clarify, because the audience is not entirely familiar, when we're talking about phenomenal, we were just saying that the participant was shown the actual color blue rather than word.
Yeah.
That's all. Okay. Um, anything else to discuss regarding this paper?
When I see in figure 6, it is a tree-like structure, right? So I read some paper that saying that emotion can be better represented by this kind of tree-like structure rather than dimensionality kind of geometric structure. I think if the object have clear subset relationship, yeah, maybe tree-like structure is more better to represent this kind of quality of structure. And then another question is how to compare between two tree-like structure. Yeah, that's what I recently thought.
How to compare between two tree-like structure? That's
Yeah. So, because at the beginning of this paper, it says that because the axiom of triangle inequality, this geometric axiom, it is not very feasible to represent something in geometric structure. But if I represent the qualia in a tree-like structure, how can I compare them? Because previously in the geometric structure, we use some kind of alignment, this a structural comparison. But for tree-like structure, I now I don't know how to compare between them.
yeah, I have no idea either. Um, I feel like in during their time they haven't even thought about these comparison of structures from one population to another. They're just happy to find out one representation, and that's good enough. Yeah.
All right, that's all from my end.
Anything more from you, Vishaal, or no?
No, not really. This is it's a pretty new area for me. I've not done any similarity experiments, so any theoretical reading on similarity experiments. But yeah, it did give me somewhat of an idea to explore. But that's like a conversation for later or something. Yeah.
Well, that's me as well. I don't have any more to discuss, so I guess that's it. Thank you for coming to the Journal Club once again. We'll see you next time. Bye-bye.